Alright, so today we're still graphing radical functions, but today we're going to focus on determining the domain and range. Okay, still talking about the two functions, square root of x and cube root of x. Okay, but today our focus is the domain and range of these two parent functions and any variation, so any transformation that was applied to these. Okay, so think about domain. Alright, we've talked about those in previous courses. Okay, but the domain are all the values for x. Okay, all the possible values for x. Okay, so if you want to write that down, domain are all the possible values for x. Or all the x values. Okay, that's what the domain consists of. Alright, and the range, okay, if the domain deals with the x values, the range are the y values. So all the y values. Okay, and both the domain and range are specific to that function. Okay, both the domain and range are specific to that function. Alright, so let's first look at the cubed root of x. We look at the cubed root of x and we want to figure out the domain and range. Right? It's always easier to determine these two by looking at a graph or having a visual representation. Alright, so if we look here, if we're looking for the domain, we're looking for the x. So all the possible x values. So primarily focusing on the x-axis, and we'll see that this function, this arrow indicates that it continues. Okay, this function will continue on and on and on all the way with all the positive x values, and will continue on and on and on for all the negative x values. So in other words, the domain are all the real numbers. Okay, the domain is all the real numbers. The x values will be every single value. Okay, all the real numbers. And the range is the same as well. Even though this looks like it may be tapering down, okay, it will still continue to go up for forever. It will never curve down. It will always continue to slightly go up. Alright, so the range is also all real numbers as well. It will always go down. So the range is also all real numbers. Okay, and no matter what happens, okay, no matter what transformation we apply, if we reflect this, if we horizontally stretch it, compress it, vertically stretch it or compress it, if we move it over here or move it over there, again, if we reflect it, no matter what happens, the domain and range will be all real numbers. Okay, just have to make sure that this x is a degree of 1. Okay, if we have a rational exponent or x squared, or it may change. Okay, it may affect whether or not it's all real numbers. So whenever we have a cubed root function and x is degree of 1, no matter the transformations, we will have all real numbers. Okay, so that should be an easier problem for us whenever we see the cubed root of x. Okay, we already know the domain and range. Now the square root function, okay, the square root of x, this is one that we have to pay a little more attention to. There is a restriction, because we know that we can't have negatives under the square root. Since we can't have negatives under the square root, since we can't have our x values be negative, that affects, okay, the domain and range. There are going to be restrictions. Okay, so when trying to figure out the domain and range for a square root, you want to focus on the starting point. Okay, we talked about the starting point yesterday. You want to focus on the starting point. This will tell us our domain and range. That in the direction of the function. Okay, so this function, it starts at 0. Okay, so x can be 0, so x is going to be greater than or equal to 0. Alright, it's greater than or equal to 0 because it goes in the direction positive. Okay, it goes in the positive direction. So you have 0, 1, 2, 3, 4. it's going to be x is going to be greater than or equal to 0. It's going to go on for forever. Right? With the range, okay, the y's also start at 0. This point here is also at 0, 0. The y coordinate is also 0. So this starts at 0 and it's equal to, it's shaded, okay. We can have 0 under a square root, and then that goes on to infinity. So hence the reason why that is y is greater than or equal to 0. Okay. Now for the domain, here it says domain, and I'm just going to use the letter D to represent domain. X is greater than or equal to 0. Alright, well this is inequality notation. This is correct. When asked for the domain, you can simply put this, or you can put all real numbers, or we also learned, okay, that symbol. You can put either one of these. Okay. Just put the quarter on the desk. Okay. So we have to keep in mind the other two notations. Alright? We have interval notation and set builder notation. Okay. Just different ways of expressing the values, okay? Different ways of expressing the domain, alright? If we were writing an interval notation, that's a notation that involves brackets and parentheses, okay? If you remember, we use a bracket when we're including the value and a parenthesis when we're not including the value. So in this case, it's x greater than or equal to 0. So since it's equal to, we include it. So we have a bracket, the number 0, okay? And 0's first because that's the smallest number, alright? And then it's every number greater than 0, so it goes on to infinity, positive infinity. And whenever we have infinity, we use a parenthesis, okay? You can just set the quarter on the table, okay? And so this is interval notation, alright? You can use whatever one's most comfortable, but all that's required for domain and range, as far as this chapter goes, is inequality notation, alright? And set builder notation is a lot like inequality notation, except there are braces, okay, or the squigglies, okay, and then we tell what variable we're talking about. So it's x such that, and this line here means such that, okay, x such that x is greater than or equal to 0, okay, and then we tell what kind of numbers are greater than or equal to 0. So x is an element of the real numbers, okay. When we say that, so we know that all the real numbers greater than or equal to 0. So it's x such that x is greater than or equal to 0, and all those numbers are real numbers. That's what set builder notation tells us, okay. So the reason I'm showing you this is just to keep in mind that and understand that these are all equivalent to each other. These all mean the same thing, okay. But all we're going to be required to do is just this, alright. So that's how we find the domain and range, okay, or specifically the domain and range for these two parent functions, alright. So now let's turn, I don't even know if I told you guys, but this is page 166. Okay, this is page 166 in your student journal. Alright, if you turn the page, okay, now turn to page 168 in your student journal. Turn to page 168 in your student journal. Give you some time. Alright, we're going to look, problem number 1, we're going to find the domain and range here. Okay, if we're trying to find the domain and range, okay, for number 1 on page 168, we can, don't worry about graphing it right now, or graphing the first one, because this cubed root function here, we know based off our notes that when we have the cubed root or any variation, the domain and range are all real numbers, okay. So your domain here is all real numbers, and the range is all real numbers for number 1. Okay, and to graph it, you can use your calculator or plug in points. Alright, and you'll see how to do that in the second example. Just to save time here, I just want us to understand that the domain is all real numbers and the range is all real numbers because this is a cubed root function, okay, and our x is degree of 1. Okay, our x is degree of 1. So now, this here, this function, number 2, alright, this 1/2, okay, this 1/2, this exponent, this rational exponent, 1/2 is still a square root. Alright, this is still a square root function. It's just written in exponential form. So let's convert this back to a square root function. And the way you do that is you keep what's on the outside the same, but this part here, instead of x minus 5 to the 1/2 power, this is going to be the square root of x minus 5. Whatever was in the parentheses goes under the radical. Okay? Goes under the radical. So, the reason why this is still a square root function is because we know that the numerator is the power and the denominator is the root, and root 2, okay, is equivalent to the square root. Okay, the square root is root 2. So all we're doing here is writing a radical instead of an exponent, and whatever was in parentheses goes under the radical. Okay, so now let's find the domain and range. Okay, now when finding domain and range, we want to have a graph. We want to understand. We want to have a visual representation. We want to be able to see it. Okay, so what we're going to do is we're going to create a table and we're going to plot points. Okay, we can always use a calculator. All right, we can always just plug this into the calculator and look at the graph that way. But if we don't have a calculator, we have to know how to plot, okay, or graph this equation. Alright, so what we want to do is we want to choose x values and figure out the corresponding y value for it, the corresponding y coordinate. Okay, now the point that we want to start with, the first point that we want to find is the starting point. Okay, if you think about square root function, it has a starting point and then it goes on. Okay, we want to find this point here. The way you find that is by having your square root, okay, whatever is under the square root be 0. Okay, that's where whatever function you have, that's where it will start. Whenever the square root, okay, what's under the square root is 0. And we know that because we cannot have a negative number on the square root, under the square root. So the first point that works is whatever point makes the part under the radical 0. Okay, whatever's underneath the radical 0. So here we want to find out what value of x. I'm sorry, that was a minus 5. I don't know why I have 4 written there. Okay, it says minus 5. We want to find what value of x makes this part here 0. Okay, so this is x minus 5. Alright, so to get 0, x needs to be 5. So we're going to plug in 5. 5 minus 5 is 0. Okay, 5 minus 5 is 0. The square root of 0 is 0. 0 times 2 is 0. And 0 minus 4 is negative 4. So all I did there was plug in 5 for x and then figure out what that all equaled. Okay, so what that means is if we have, okay, I'm going to draw my y and x axis. Okay, if we have that there, that means that this is over 5. 1, 2, 3, 4, 5, down 4. 1, 2, 3, 4. Okay, we have our first point, we have our starting point. Okay, and now let's find another point to plot. Okay, If we plot a number less than 5, if we try 4, well, 4 minus 5 is -1, and we can't have a negative number on here. So we want to do a number greater than 5. And we want to choose a number that we can easily take the square root of, okay? We want to choose a number that makes this whole thing under the radical a perfect square, okay? So if we try the next number, if we try 6, 6 minus 5 is 1. Well, 1 is a perfect square. 1 times 1 is 1. So that's a good number to use. So let's use 6 next, okay? So 6 minus 5 is 1. The square root of 1 is 1. 1 times 2 is 2. And 2 minus 4 is -2. So here we have 6. 1, 2, 3, 4, 5, 6, down 2. Okay, so next point. Alright, and so we have 2 points, but really, even if this is our starting point, we want to be sure of the direction it's going. So let's find one more, okay? We plug in 7. 7 minus 5 is 2. Well, we don't want to take the square root of 2. Okay, that's not a perfect square. It's not going to be a nice number. Alright, if we try 8, 8 minus 5 is 3. If we take the square root of 3, that's still not a nice number. So what about 9? 9 minus 5 is 4. Well, we know the square root of 4. Square root of 4 is 2. So let's plug in 9. Okay, and we said 9 minus 5 is 4. And the square root of 4 is 2. 2 times 2 is 4. And 4 minus 4 is 0. So here, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So about right there. I know it's off the graph, but that's where 9 would be. The point 9, 0. Okay? So now we have 3 points, and we can draw our graph. So start at the starting point right here and draw your square root function. Okay? Sketch it. So now that we have a visual representation, we can find the domain and range. Okay? So the domain, we're going to look at the x values. Alright, and we said we want to focus on the starting point. So where do the x values start? Well, 1, 2, 3, 4, 5. They start when x equals 5. Alright, so we know we have 5 out here, and we know we have x. Okay, we know we're talking about the x's, and we know we have 5 here. Well, are the values greater than 5 or less than 5? Well, they're greater than 5. They're going this way. Okay, so the domain is x is greater than or equal to 5. And it's equal to because it's a solid dot. Okay. The range, we're going to do the same thing. Okay, the range, we're going to look at the y values. So 1, 2, 3, 4 starts at -4. So we have y -4. Then we have to figure out, is it greater than or less than? Well, the y values are all greater than. So it's greater than or equal to. Again, because it's a solid dot, it's equal to. So this is how you find the domain and range. Okay? Again, if you have a calculator, you can just plug this in and you'll get this function here, get this graph. And from the calculator, you can just determine your domain and range. But when you don't have one, you have to plot the points. You have to plug in x values into your equation. And anytime we have a cubed root function, okay, the domain will be all real numbers and the range will be all real numbers, as long as our x has a degree of 1. It's just x to the first power. Okay? So, the other thing that we're going to do today is learn how to solve a specific word problem. Okay? And you'll need a calculator to do this. Okay? Some sort of calculator to do this. Alright? I'm going to show you guys how to use the calculators we have here. Okay? So go ahead and get a calculator. Graphing calculator. Hopefully you can see what happens, okay, on the calculator. But, alright, this problem says the table shows the numbers y of seconds it takes a dropped object to fall x feet on Saturn. Write a function that models y in terms of x. How long does it take a dropped object to fall 15 feet on Saturn? Okay. So, what we have here, what it's asking for, is to write a function that models this table. So we want to write a function that represents this table, and once we find that function, we want to plug in 15 and find out how many seconds it takes for the object to fall. Okay. So, the way you go about solving this problem is by creating a table. Okay. We have a table here, but we want to figure out, okay, what parent function, okay, what's the parent function that represents this data, okay, or what parent function is this data here a variation of, okay. So we've been talking about square root functions and cubed root functions, okay. We've been talking about these two here, square root of x and the cubed root of x. So we first want to figure out what does this data more closely resemble. Okay. Well, what you want to look at is your x values. Okay. We know that a square root function, our x's always have to be positive, and the cubed root function is always is negative or positive. It can have both values. Well, look at this data here, this table. All of our values are positive. Okay, so that means that we want to use the square root. Okay, we want to use the square root of x. Okay, that's going to be what we compare. So what we're going to do is, okay, once we find out the parent function, okay, we look at the x's and determine that, the one that we're going to compare. Okay, we then take out our calculator. Okay, take out your calculator, go down to add list and spreadsheet. Okay, what we're going to do is we're going to create a table that compares these two. Alright, so the table, your first column is going to be your x's. Okay, second column, hit enter. Second column will be the y's. Okay, and here, this equal row, this is y equals, okay, and we can put a function in here. Alright, we can put a function here. Well, the function we want to use is the only function we know so far, and that's this parent function, the square root of x. So let's put the square root of x in there. Okay, hit enter, and it asks us, is this a column or variable reference? Okay, well, we're talking about a function here, so it's a variable reference. Okay, we want x and y to represent variables, so we hit OK, hit enter, enter. So now, whenever we put an x value here, okay, it will give us the corresponding y value based on that y equals the square root of x. Okay, so what we're going to do is we're going to use the x values they gave us. Okay, the x values they used. So that those were 0, 10, and as you go along, you'll see that it will find the square root. Okay, the square root of 10, 20, 30, and 40. So all the x values they used. Okay, so now we want to compare these values to the values for the function we don't know, the function we're trying to find. So those values were 0, and we'll just manually enter in these. 3.5, 4.9, 6, and 7.1. So we found these. Okay. How you doing?
Working?
Yes, sir. Yes. Okay. So now that we found these, so now that we've found these, we then want to figure out, okay, this function here. Okay, the function we don't know. The way we do that is by figuring out the transformation that occurred. Okay, what transformation was applied to this function, to these numbers, that gave us these numbers. Okay, and that transformation has to be constant. It has to be the same. Okay, we have to find the one transformation that made these values here become these values. Alright, well, the way you find that, okay, the way we're going to find that is by dividing 3.5 by 3.162, and then we're going to round that the fourth decimal place. We're going to round that up. Okay, so it'll be 3.1623. Basically, what we're finding then is what was multiplied by this value here to give us 3.5. What did we multiply to give us this? So to do that, we have to divide. So 3.5 divided by 3.1623. So whenever we're just carrying out the operation here, the division, just use 4 decimal places. And then once we figure this out, let's round. Okay, we're going to round. Once we have working with answers, just use whatever just use one decimal place to represent an answer. Okay, so 3.5 divided by 3.1623, and that equals 1.106. Okay, and we're just going to round to 1.1. We're just getting an estimate. Okay, so that's about 1.1. Okay, now you then, going back to your table, okay, let me go back to the table. Alright, you then want to do the same thing for these values. So do 4.9 divided by 4.4721, and continue to do those for every pair. Okay, for every pair that we're comparing. And each time, if you round it to the one decimal place, you just round it up to the ones decimal place. Okay, we will get 1.1. Okay, you'll get 1.1. So that means 1.1 was multiplied. Okay, we multiplied this function by 1.1 to get all these values. Okay, so this number here that we found, 1.1, that's how we're going to write our new equation. Our new equation is going to be y equals 1.1 times the square root of x. Okay, 1.1 times the square root of x. So we just found the function, okay, that models this set of data. Okay, found the function that models this set of data. So now all we have to do is plug in 15 to the equation and solve. Okay, so it'll be y equals 1.1 times the square root of 15. Okay, so go to menu. Okay, calculate, and this is 1.1 times the square root of 15, and that equals 4.2, and then that 6 here, okay, 4.26, let's round that, so that'll be about 4.3 seconds. So that's about 4.3 seconds. Since we're talking about time, they just want to estimate, and your book just rounds to the first decimal place. So just round it to 4.3 seconds. Okay, and that's your answer. So you have your equation that you found that represents this data, and then the answer. Okay, and you'll have 2 problems like that on your homework. You have 1 on your assessment like that, and then 1 on your test. Okay, so this is something we need to know. Alright, so go ahead, use this. Okay, if you don't have a calculator, you can always come in before or after school or use an online program. Okay, an application on your phone or online that can you can generate a table. Alright, okay, well, you guys have a good day.